Have you ever tried to play a retro video game on a modern TV or monitor only to find it didn't look as good as you remember?
Wow, does that ever look like dog crap?
It's puzzling considering that current displays are considered superior to old school CRTs in almost every way. But believe it or not, this is actually the problem, as retro games often took advantage of the imperfections of CRTs to produce an overall better picture, huh? But how the heck does this work? To find out, we spoke to Mike Chi over at RetroTink, and we'd like to give him a shout out for helping us out with this video. Thanks, Mike. There are actually several factors that go into achieving that classic game look, but one of the most important is the fact that the processors inside those retro consoles were only powerful enough to output a low-resolution image with a limited number of pixels, colors, and visual effects. And you can see this easily on a modern display. Colors and shapes often seem rather sharp and flat, as whichever color a pixel is programmed to be is exactly what you see on your screen. But when you connect to a CRT, a couple of wacky things happen. Many old school consoles used either an analog composite or RF connector, the ones that you had to screw in. The console's digital data on individual pixels would be smashed together into an analog waveform and sent down the cable to the TV, which would try to pull the signal back apart. Oh, what did you guys do to this? Not only were TVs just not very good at perfectly reconstructing these signals, but the nature of the picture tube itself introduced further artifacts. Because CRTs created images by firing a beam of electrons onto the glass, some of those electrons would hit outside of their intended areas. Think about how a flashlight illuminates objects outside of whatever you're actually trying to look at. This created blending effects that could actually make images look more detailed. For example, in this screenshot from Sonic the Hedgehog 2, you can see how the analog nature of the signal and CRT blurring actually creates a transparency effect on the waterfall from the alternating light and dark bands, an effect that isn't present on an accurate modern display. Accurate. You can also see how dithering, or intentionally adding noise to a signal, just looks kind of dotty on a modern display, but gets nicely blended on a CRT, like in this spotlight from Streets of Rage 2. Developers understood these effects and would often intentionally try and create their games so they'd generate artifacts in a desirable way. But because these were hard to predict, this was likely done through a trial and error method, with developers tweaking how their game looked on a CRT until it was just right. But there was also an important unintentional consequence that made old games look better on CRTs, and we'll tell you all about that right after we thank Linode for sponsoring today's video. Linode is a powerful but easy to use Linux-based cloud computing service from Akamai. They have a large marketplace with one-click apps to quickly deploy servers for website development, file hosting, database management, video hosting, or even video game servers. So, Linode's affordable pricing has no hidden fees, and you only pay for what you use. Best of all, Linode has worldwide data centers and 100% human 24/7 365 customer service that's reachable by phone, email, or social media. Slide into their DMs. Sign up for a free account today and get a $100 60-day credit on your new Linode account at the link below. Remember how we said that those old consoles had limited color palettes? Well, the blending you see as a result of analog signals and picture tubes also meant that new colors would be created, which proved to be quite important as the NES only supported 56 colors, while the Sega Genesis could only show 61 colors at the same time. These intermediate color artifacts would often add detail and depth, as well as hide sharp transitions between colors that would otherwise make the game appear less detailed. And although the examples we've shown you so far have been from 2D games, the blending effects of old TVs remained important well into the 3D era. This was especially evident with Nintendo 64 titles, which can appear very aliased or jaggy on flat panel displays. Because of CRT's natural blurriness, that undesirable sharpness, was usually hidden by an accidental but very practical form of anti-aliasing. Not to mention that the upscalers in modern TVs often don't know exactly what to do with a signal from an old console and therefore don't do a great job upscaling them. They're not retro enthusiasts like you. Most retro consoles, whether 2D or 3D, output at a resolution of around 240p, but TVs are built more for resolutions of 480i and up, since that's what's used by most broadcast and streaming content. So what should you do if you want to play old games but don't have a bulky CRT lying around? Emulators for your PC often have settings you can play around with to simulate these old analog effects, so fiddle with them until your game looks close to the way you'd like. Alternatively, the passion of the retro game community has yielded a growing number of hardware solutions that you can rig up between your console and your TV to get a result very close to what the developer intended. Although first-party products like the classic consoles on store shelves nowadays do offer some crude CRT filtering features, as with many things in the tech world, the community-driven projects actually can produce better results. It's something about having passion, being interested, caring about stuff, like just a passion project, something like that. And thank you for being passionate enough to watch this entire video. Hey, like the video if you liked it, dislike it if you disliked it. Maybe you watched all the way to the end because you're like, I need to let them know how much I hated this. Check out our other videos, comment below with video suggestions, and don't forget to subscribe and follow TechQuickie if you didn't hate this.